Hello and welcome back to the final video in this three-part series on the 2x2 systems of differential equations. So today we're going to be taking a look at the repeated eigenvalues case. And this comes up when you only have a single eigenvalue in a 2x2 matrix, right? So here is kind of our strategy, how we want to approach these problems. Like, we want to begin by finding that eigenvalue, and then obviously the corresponding eigenvector. And I'm going to call that v, right? So we're going to then set up this following equation, right, where lambda is defined and so is v, and we're going to be solving for this w, right? And once we find that, we have a general solution, and it's in the following form. C1v e to the lambda t plus C2 e to the lambda t times vt plus w. So this is actually a little bit reminiscent of what we did with our second order constant coefficient linear differential equations, or sorry, not, yeah, so differential equations, where you do like t e to the t and e to the t, but we have this additional little thing as well. Yeah, so that's pretty much all there is to it. Let's take a look at some examples that'll really make this more concrete. So as always, we begin by finding the eigenvalues here, and let's just start off with that. So let's find, we have m, we're going to say, is the sum of the diagonal elements divided by 2. So we have negative 2 plus 12 is 10, divided by 2, we have, oops, we have 5. And then for p, we're going to just take the determinant, which is negative 2 times 12, so negative 24, minus 49, which is negative 7 times 7. So that all ends up being just 25. So we have that lambda is equal to m plus or minus square root of m squared minus p, which is just going to be equal to 5. So writing this over here, we have, let me rewrite that lambda. We have when lambda is equal to 5, this is going to be the following matrix. Okay. And now we're just going to go ahead and do our normal stuff, just row reduce. So I'm going to do 1/7 times row 2, and I'm going to have row 1 plus row 2. We're going to end up with something that looks like this, and from here, I'm just going to say it's going to be 1, negative 1. That's going to be our v. So we're in a good spot. We've found our lambda, and we found our v. All that we need to find now is w. Now there is actually kind of a fast way to find w, but before we do that, I kind of want to show you like the context behind it, maybe more like how we would go about doing that. So let's just have x of t, right? We're gonna actually make a guess. So we're gonna say x of t is equal to e to the 5t times vt plus w. And then we're going to take the derivative of that, and that's going to end up being, we'll have 5e to the 5t times vt plus w. And since we're going to be doing some product rule here, we'll have plus e to the 5t, and then the derivative of this thing over here is just going to be v. So next what we want to do is kind of plug all this stuff back into what we began with over here. So on the on the left-hand side, I'm going to have x prime. So I'm going to say we have 5vt e to the 5t. I know it's a lot. Plus 5w e to the 5t. Plus we have v e to the 5t. And I'm going to say now that's equal to, so first we're going to multiply everything, all these x terms are going to be multiplied by a. So we have a v t e to the 5t plus we have a w e to the 5t. So e to the 5t is never equal to 0. So we can actually cancel that out from all the terms. So that's going to make this a little bit easier to solve, which is did. And so we have our first equation, which is everything in the red. And we're going to kind of just like forget about the t's for now, because when t is equal to 0, it's not really that interesting. And we end up with this following equation. We have AV minus 5V is equal to 0. And the solution to this, right, we're going to be solving for V, because we already know A. V is just going to be what we had over here before, right? And this is always going to be the case, because this is essentially just an eigenvalue equation. So this V is just going to be the same thing that we found before. Now, our second equation here is what's in the blue, and that says we're interested in AW minus 5W is equal to V. And now you might notice this looks very, very similar to what we have over here, right? So essentially we're going to set up something that does look quite similar, and it's going to be just this. So when we subtracted the 5, we ended up with this. So I'm pretty much going to just bring that whole thing down. We have -7, -7, and I'm going to augment it with V, right? And when you do this, always, always, always make sure you bring this matrix down. If you bring this thing down over here, you're going to get no solutions, and that's not a good place to be. So you always want to end up in a spot here where you have a row of zeros. So I'm going to do R1 plus R2, and we're going to end up in a pretty good spot as anticipated, right? So you want this row of zeros. You always want to have that last zero over here. And if you accidentally bring this thing down over here, you're not going to get that last zero, and that's going to be a pretty bad spot to be in. So rewriting this now, we have 7x plus 7y is equal to -1. And I'm just going to say, let's say y is equal to s, right? So now solving for x, we have that x is equal to -1 minus 7s, and the whole thing is divided by 7, which is the same thing as saying -1/7 minus s, right? If you're kind of confused what just happened, I just rewrote this thing, right? So I said that subtract 7y from both sides, right? And that's 7s, and then we divide everything by 7 because we have 7x over here. So we just did some algebra kind of quickly there. Okay, and then obviously before we said that y is equal to s. So the whole thing, right, writing out this whole vector w, we're going to have an s part, and so the part of x that was s is just a -1, right? So we have a -1 over here, and then y was just +1. And then we have a constant part, and with this one we have -1/7, and then we have 0. Nice. Okay, so bring everything finally back together. Let's write it all out. So we have our C1 e to the 5t, and we're going to say 1 -1 plus C2 e to the 5t. And I'm going to put these parentheses over here. And looks like I'm kind of running out of space, so I'm going to shift this whole thing over. And so we have our VT, right, that I talked about before. So I'm going to say T over here. And then we have 1 -1. And then I'm going to add, what do we have over here? So we have this whole thing over here. This kind of, so I'm actually just going to copy and paste that. That'll probably be saving me some time. Okay. Now I want you to notice something here, right, before we write our final general solution. And that is that this term over here is actually saying the same thing as what we have over here, right? Because here we have some arbitrary constant, e to the 5t multiplied by this vector. And here we have another arbitrary constant, actually 2 being multiplied with e to the 5t and then that same vector. So you might notice that this and this, like it's actually just off by a factor of -1, this vector and this vector. So these two are kind of giving the same information, and so we can actually, oops, don't want to erase too much, but yeah, we can actually kind of get rid of that whole thing. And the nice thing is that this is always going to happen. So let me actually just box this answer in. But essentially what I'm saying is when we get to this part over here where we have to solve this like equation, there's always going to be like an S part, or like whatever letter you want to call it. Just don't use T because that's actually kind of different. So some S multiplied a vector, and you have some constant. This constant is going to be our W. This part we're going to kind of kick out because that's repeated information. So that's always going to be the case. And that's that. That's our answer. Awesome. Let's take a look at our next example. That one I'm not gonna do this like this whole kind of like middle step over here ends up being quite long. You can cut that out, and by cutting that out, you can see that it's significantly less work. Great. Let's find our eigenvalues. So we have that the sum of the diagonal elements is 6. Average of that is going to be 3. Our p is going to be 1 times 5 minus -4, which is just going to be 9. So lambda is going to be 3 plus or minus square root of 9 minus 9, which is just going to be 3. Plugging that in over here, we're going to end up with this matrix. So we're going to have -2, 2, -2, 2. So quite similar to our last one, actually. So I'm going to say 1/2 times, 1/2 times row 2, and then we'll say row 1 plus row 2. So it looks like we're actually going to end up with the same eigenvector as last time. And that's going to be 1, -1. Got the B on the wrong side. Okay, so now we can jump quite a few steps, right? And essentially what we're going to do is we're going to take this thing over here, and we're going to augment it with this vector over here. So we have something that looks kind of like this. We have -2, 2. Like I said before, this should always work out nicely. If it doesn't, it means you might have made a mistake somewhere along the way. So I'm going to call this one R1, and I'll sum the 2 rows here. Okay, things are looking pretty good. And we have 2x plus 2y is equal to -1. I'll call y equal to s. Then we have that x is equal to -1/2 minus s. And then y, I can just say 0 plus s, I guess. Okay, nice. And then we can just write out the whole thing. So we're going to have our s part, which is going to be -1, 1. And then we're going to have our constant part, -1/2, 0. So like I said before, right, this is going to be our w. Let me actually write that so you guys know. This is our w vector. And you can see, like I said before, that this whole thing over here is like repeated information. It's just a multiple of this. So all the part we're interested in is this thing over here. And that's pretty much it. We can just jump straight ahead now to our general solution. We have all the information that we need. So we have c1 e to the 3t multiplied by our vector, 1, -1. Then we're going to have c2 e to the 5t, parentheses over there. Again, running out of space pretty quickly. So then we have our t that goes here, 1, -1. And then I'm going to add -1/2, 0. And that's all there is to these kinds of problems. Hopefully that made sense. If there's something here maybe went a little too fast over, didn't add up, just feel free to leave some comments down below. But that's all for this video. Thank you guys so much for checking it out. Hope this helped.